Okay, so let's start. Before I start, I would love to give you a short introduction in the Dizzy hashtag. You see it in the upper left corner every time. There will be a video or a GIF on the next slide. So for those who are not sure what this is about, it's for people who have, for example, motion sickness, so they won't be surprised and just can enjoy the talk. My name is Ola Gasidlo. I'm a senior developer at Stala. I'm CTO at JS. I'm organizer of a lot of conferences, meetups, and stuff in open source. So today I would love to tell you a bit about the actual state of offline first, how our point of view has changed in the past few years, and how it's adapting to the real world, actually. So, the internet. It turned 27 this year, so happy birthday. Woo! Yeah. In this time, our relationship with the internet, it changed a lot. We do different things with different devices than 27, 10, or 5 years ago even. We rely on our devices, the internet, but our needs changed. So, tell me, by raising your hand, who of you gets a lot of work done with just one service like GitHub is down? Wow. Who of you ever lost their folks, for example, at a concert or event and wanted to, or maybe just to meet up, and had difficulties because everyone used the same mobile network? Even more. Okay. So, who of you ever heard about the offline first concept? A lot? Okay, cool. Who's already building offline first applications? So, okay. So, 3 years ago, when the offline first movement got broader attention, I gave my first talks about the concept. That was 2013. What was our idea back then? Why did we need the offline first concept so badly? First thing was the rise of the mobile devices and their usage. There are countries where people do not even use desktop devices at all. Still makes sense, especially when you think about how cheap a mobile phone is in comparison to a laptop, for example. And it is enough when you consider what you're actually doing with that. There's also the issue of no constant connectivity or poor network coverage. Here, offline first felt like a huge enhancement to our application and adaptation to new behavior. 3 years later, in 2016, what do you think? Why do we need offline first concepts, and do we still actually need it? After seeing offline first in the wild, we've realized it's not just about special use case or the rise of the mobile devices. It's about the whole approach. It's just so much more. Offline first means getting on screen without a network request. The more that it's there before the network, the more offline first it gets. This means that every web application should work without a connection after the first visit and just use network for getting and setting your data. Everything else is online first. So, tell me again, who of you thinks they're following correct approach to make applications offline first? Just raise your hands. The thing is, there's still no perfect path, so when you're doing it, you're probably doing that right. So, we're still trying to figure that out. Who of you thinks that offline first is a progressive enhancement? So, not many people, but what if I tell you that you're actually wrong? So, let's take a step back and see, why do we need applications? Normally, we use applications for everyday life to make our everyday life easier. So, checking out in with family members, loved ones abroad, maybe just texting your partner during the day. Using Slack, RC, etc. at work, especially in remote teams. It all comes down to communication. We also need applications for tracking data. Did I drink enough during the day? How many steps did I make? How much money did I spend? Also, how can I fix my bike or even my washing machine? How do I translate that sentence, or even did I spell that right? Basically, this is all about information. Posting selfies from your last vacation, tweeting your thoughts, checking in symptoms when you're sick, or even check the internet while your kids act out. I do that all the time. So this is about empowerment. And the most important thing there is cat gifts. I think this is a basic life need. I think we all can agree on that, right? Cool. So this is all about love. Communication, knowledge and information, empowerment, love. This all sounds like something we all have in common, right? So when we break that down, it all comes down to help satisfying our very basic human needs for safety, belonging, esteem, and self-actualization. Maslow defined those points in his hierarchy of needs already in 1943. So since when is helping people to fulfill a basic need progressive enhancement? This is why I think putting offline first in a progressive enhancement, and sorry, don't listen, bullshit. The network is the progressive enhancement. The tools are, but not the concept. But we all too love to sell it that way. So developers jump on the progressive enhancement train and redo their applications every 6 weeks in a new cool framework or whatever, without knowing what the real issue is they're actually solving. To be honest, really tired of half-done applications which are released out in the wild without any kind of documentation because someone wanted to refactor the app and the new cool stuff. Temporary, right? Temporary. So temporary workarounds, awesome. Super slow applications because of really bad planning and messy architecture. I mean, rethink. We do not need a new Uber or Twitter, really, trust me. What people definitely, and we should want, are solid applications that match our very basic needs and that actually work. We tend to forget that our jobs, are about humans, about people, not about tech, not about frameworks, not about design patterns, especially because usually you end up with the gorilla banana problem. You wanted a banana, but what you got was a gorilla holding a banana and the entire jungle. Every time you use the whole infrastructure in like a framework to solve one problem, you get all this implicit environment that they carry around with them. Say goodbye to the new fancy stuff, it's fine. Focus on the basic needs of the user, fulfill them by 100%, otherwise the user will solve these issues by themselves. Starting from using the application in a very unconventional way, you might know that, to even hacking a fix. Let's check out how this looks like and what we can learn from the real-world issues here. I've picked up 5 kind of interesting ones for you, and I hope you like them. So let's start. The rally. Any one of you heard about the Mongol rally before? Could you just, so I know? Okay, not so many, okay. So it's an unconventional rally where people start from London or the Czech Republic to drive down to Mongolia. The main intention was that to donate your car program, where every car, which had to be old, that actually makes it to Mongolia, can be donated without import duties. 2009, a team from Spain took part in the rally. Nothing special here at first glance. Well, the issue at the rally was they had to cross a lot of countries, different reception, different payment models for data volumes, etc. So they needed a way to communicate with the loved ones. And so they just can say like, okay, I'm alive, I'm well, I need money, whatever. They built a system that could actually decode an ASCII message in 8-bit binary code, ran that through 8 phones that actually called just one number. To save money, they didn't establish a full connection, so it was all about letting it ring. The short ringing was a 0, the long was a 1. The other unchecked the numbers, which were set for the order of the bits, and coded the binary back in ASCII and sent out the message to the loved ones. Humans, right? So what are your learnings here? Unidirectional communication, very basic, still not done right. Using networks and technology that are already there by enhancing it and using a different approach without new tools. The team rethought how to use and made the base better to match their needs. They didn't research for new tools, just used everything they had at a very low level. They fixed it already in the beginning by thinking about the real issue and not the solution. So, if you enjoyed that one, next one up. The router. Imagine a beautiful morning. You've decided to work remotely, as we all do on our vacations, and sitting in an internet cafe. You'd love to check your email, right? So, connect your laptop to the router, open your email program, send the request to get the emails. Close your laptop, come back in the evening, and you're like, wait, what? Evening? You might ask why. Well, there's no physical connection to the internet like a cable. They're just having a router that saves the request and connects via Bluetooth to a bus. It syncs the request and off it goes, literally. So the bus arrives at a stop after half of the route to get to the hotspot, actually with a physical connection, and syncs with another bus. They do not even exchange the data, but also passengers. The tech behind the SNC service is a combination of NAT zones, DTN routing, and the darknet, not to be confused with the darknet, please. You can find more information in the slides. So, what do we learn here? Actually, check your requests, because you should be actually aware of what you're doing. So, do you need 20 requests, or maybe just 2 would be enough? And yes, the size of the files does matter. So please uglify and minify your files. Do you even need that 5 MB background for mobile? Not sure? Besides from the assets, which data do you want to send and receive? Maybe just a part. What about partial responses, failed success messages after the sync because success actually didn't make it to the client, although the data was synced on the server? We do not have many possibilities to actually solve those issues by syncing or rechecking, just a very small amount of requests. And decouple the server and the client. Build in a task and message system, because it won't break. You don't need to build that by yourself. For example, for data, CouchDB, and especially in combination with CouchDB, prove the usability in the real world really, really well. So, next one, the agent. A lot of countries are known for the bad connectivity situation, but the thing that most people do not know is the infrastructure might not be the best, but this is not what makes the connection really slow. We need to take a look somewhere else. For example, Iran has packed their routers full with spyware. So it checks requests and also the send data up to 120 times. And this is what makes the request that slow. I used to work for a medical company which served patient data in Iran for hospitals to radiologists who could review the data and make the diagnosis on the fly. The images were requested in very high quality, as you can imagine, to make the diagnosis as solid, as fault tolerant as possible. We developed an algorithm that improved the compression rate from 2 to 3 to 1 to 6 without losing quality. Very good first step, but still not enough. We had to make sure that other assets, for example, UI was already there, so data that was requested were as small as possible. What are our learnings here? We need to minify and uglify our assets. Already had that. Also save the assets on first load without requesting it later. The update cycle for assets and data, this should be separated. The update from assets is less important than syncing the data. This is why you need to take care of responsibility for your caches. What would be a better way to do if not service worker? For migration from app cache to service worker, but also if you want to use the app cache for quite a bit, please check out the JCache. Also, saving images in the in-browser storage are a good way to go, but it's still very painful way because storage limitations and very different implementations of storage limits. Porting decorative images like icons and logos to SVG and CSS is a great way to cut off a bit of the overhead. Encoding assets in base64 and storing the string in browser storage of your choice could be a way to go. For example, saving fonts like that and also loading them straight from the storage improves the performance a lot. This is even possible with images like a logo, but please just do not do that. This is all with all of your images, just because you can. Don't build the town because you just need one house. The strings are huge, and we all already know, and in-browser storages are limited. And the last one, the last learning for this example. Encoding base64 on the fly is a very heavy task, so it slows down your site, especially in combination with dumb manipulating frameworks like React. You'll also find yourself running into race conditions. So, are you still awake? Just nodding? Shaking? Cool. Awesome. So the next use case is a little bit heavier, just to let you know in advance. So next one is the pandemic. Trigger warning of death. So 2014 and 2015, the Ebola pandemic in parts of West Africa was a really scary issue. I was involved in a project by the NGO eHealth Africa that built 2 applications to help stop the pandemic. So the first issue we tried to solve was providing information for a population. People got informed about one number they could actually call to ask about symptoms, to report someone sick or even dead. The call center tracked the calls, collected all the provided information from the caller, and sent that out to a team if needed. They added information through an interface, like name, position, additional information, also the number of the caller, so they could call them back for any further questions. Data analysis and filtering was really easy thanks to that application. They fought with issues like constant power loss. The generators jumped in after some time, but the applications had to decouple client and servers, so no data was lost. You might not know the fact, but when you shut down your computer or mobile, the caches get flushed and data gets deleted, especially when you use a browser. So first learning, first application. CouchDB was exactly what CouchDB. With CouchDB, we actually have documents which are stored. This is why we also use it for storing the data on the client. Second application was to track patient data in the field. After examining the infected patients who had to stay in quarantine for 21 days. The team added the data to a general database, plus got lab results for very different entry points and very different file types, whatever, including the sync of the data across all kinds of devices. One thing we knew for sure that we had access to a network and the devices were solid. But some of them were super old, some of them were totally new, so our tool set was really limited. This all sounds super messy, right? What do you do with a mess? Exactly, you clean it up. So, next learning was, we added an interface to map the data in one defined schema, so everyone was able to import and add data on the fly. The sync was proceeded when they came back to a connection independently from how much data they've tracked already and when the last sync was back. The schema helped us a lot to prevent merge conflicts before the get-go. CouchDB and PouchDB helped us to take care of the rest. We helped to curtail the pandemic because of a clean data structure and constant testing of the applications. So if someone tells you that those things don't matter or you don't have time for that actually, now you know what to reply. So, almost lunch, last story for today, the pizza. We all love to order food, right? So, did you ever check the local storage when ordering just to see if they saved the card items in it? Anyone who already did that? It's fun, you should try it. A friend of mine did that once and went a bit further out of curiosity. He was wondering if they are actually validating the checkout on the server. So he manipulated the checkout and subtracted just 1 cent and set it out and waited. The pizza came, and no, there was no server-side validation. So, learnings. In contrast to the limited possibilities of our use case before, this company could have validated the data on the server. But it is sometimes not possible, especially when everything needs to work without any requests. Security is still a very new topic to offline first, and not many tools are provided yet. Although many of us seem to hate CORS, sometimes it provides already a really great set of rules to make the web applications more safe. But it does not solve the issues with the in-browser storage manipulation. So, one way to go would be to encrypt your data. When you use CouchDB, you can add CryptoPouch, which encrypts your CouchDB documents. Big downside here is the document get encrypted, but not the ID. So you can lead back to issues with the security again, but at least you can't change the data anymore in the console. When you want to encrypt the data, you might want to log in, right? Which does not work without a request on the server. So, ever heard about tokens? So, there's a way to use tokens in the client. JSON Web Tokens are an open industry standard method for representing claims securely between two parties, which is exactly what we want. It makes decoupled and secure sync and communication possible. So, last advice for today, please use JWT. Okay, time is up. Over time, sorry. I hope you had a great time, and thank you for listening. If you have any questions, we can go further in discussion talk, or I won't be pretty far from the screaming girls. And remember, it's not about frameworks or design patterns or tools. It's about humans. So, thank you.